Hi, this is Miss Jensen, and today we are going to talk about evaluating an inverse trig function. Okay, so just kind of a reminder what an inverse is. It's looking for the angle at a certain ratio. So if you look at this one here, it's the tan at what angle equals square root of 3. So we're looking for an angle or angles at square root of 3 over 1. Okay, so how do we find the angles? What we're asking ourselves are what angles give us a ratio of square root of 3 over 1, where, from the center, our opposite is square root of 3 and our adjacent is 1. Okay? All right, so just reminding ourselves of a few things. Inverse trig functions, what we use to find an angle. So remember, sine is opposite over hypotenuse. This is the ways that we can write the inverse. So both of these mean where is the opposite over hypotenuse, whatever that ratio is, what is the angle at the sine of that ratio? Okay, arcsin is the same thing. So how do we write the inverse of the cos? So the inverse is either cos to the -1 or arc cos. So this is kind of a review from the last unit. Inverse of tan is tan to the -1 or arctan. Okay, so those are kind of the original ones on the left, and these are the inverses. Inverse. I need an S there, I guess. So it can be one or the other for those. Okay, so again, a reminder, where are functions positive? Okay, so remember we talked about all students take calculus. Okay, so all students take calculus. That's the way of remembering it. This is where the functions are positive, where functions are positive. Okay, and then in the opposite quads is where they are negative. Okay, so this is just kind of a reminder from what we did before. So everything, that's because no matter if it's opposite over hypotenuse or adjacent over hypotenuse or adjacent or opposite over adjacent, everything is positive in the first quadrant. Here's sine, and for that matter, cosecant. Both sine and cosecant are positive here, because remember, sine is opposite over hypotenuse, or hypotenuse over opposite. So it's positive there. Tan, opposite over adjacent. Well, if the opposite is negative and the adjacent is negative, the tan ends up being positive, same as the cotan. And in the fourth quadrant, if we go adjacent over opposite, whether it's cosine or secant, because secant is hypotenuse over adjacent, that becomes positive. Okay, if we want to put those other ones there, but that's where it's positive, and then the opposite quadrants is where they are negative. All right, so this is doing the same thing we did in the last unit. It's just we're doing it in radians. So just like before, we want to identify the ratio and then draw a picture of the triangles in that given ratio. Okay, so like if I'm looking for the arcsin at square root of 3 over 2, this is positive. So I want to think, okay, I'm identifying the sine ratio. It's positive, and sine is positive in the first and second quadrant. Okay, so that's a positive ratio. I know my opposite is square root of 3. My hypotenuse is 2. So from this center here, the opposite is square root of 3. Hypotenuse is 2. So this is definitely a 1, 2 square root of 3 triangle. We only have two choices for triangles. It's either 1, 2 square root of 3, or it's 1, 1 square root of 2. Okay. I'll label my positives, negatives there, but that's where the sign is positive, is the first and second quadrant. Now, I did label my positives and negatives. Honestly, I don't care, because what I want to know is what these angles are. So across from square root of 3 is 60. So honestly, I know that the difference is that we're supposed to put it in radians. With these, I usually put it in degrees, and then I think, okay, well, if I'm going to do that in radians, where is this? So if this is 0, how do I get here? It's 60 degrees, but it's 1/3 of the way to pi. So this is pi over 3, and this is 2 pi over 3. So the two answers are pi over 3 and 2 pi over 3. Okay. Now for the second one, it's where is the cosine square root of 3 over 2? So again, positive fraction there. Where is my cosine positive? In the first and the fourth quadrant. But this time my adjacent is square root of 3. So my adjacent is square root of 3 over my hypotenuse. So that's where the square root of 3 is. This is a 1 square root of 3, 2 triangle. And I could label my positives and negatives. Why don't I? But honestly, I don't really need to, because all I really care about is what is across from 1. Is it 30, 45, or 60? And it's 30. So again, there's two different ways I could do it. I could either do it like I did before and then convert it, or I can think, okay, if this is 0 and if I'm going by 30s, I'm going to go by 6. So this is 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 8, 9, 10, 11, 6 pi, I should say. I dropped my pi there. Can't have that. So 11 pi over 6. So the two solutions are pi over 6 and 11 pi over 6. All right, a couple more. So, again, with these, I would unsimplify these first. In this case, I would change it to 1 over square root of 2. So I want to start out by thinking, where is my cosine negative? My cosine was positive in the first and the fourth, so it's negative in the second and the third. So this is adjacent over hypotenuse. My adjacent is 1, 1. My hypotenuse is square root of 2. Same here. So anytime I have a square root of 2, this is a 1, 1 square root of 2 triangle. That's -1. Again, I really don't care, because really what I want to know is what's my reference angle. And my reference angle, if it's a 1, 1 square root of 2, is 45. Okay, so let me just show you, I could go 1 pi over 4, 2 pi over 4, 3 pi over 4. I could do it like that. But also, if you really want to, you can go, okay, this is 135. So we can do it in degrees. Sorry, I'm going to get these out of here. So this is 135 degrees. This is 180 plus 45 degrees, so this is 225. So that's what my answers would be in degrees. But if I want to know what it is in radians, and I don't want to sit and go around the, 1/4, 2/4, 3/4, I can also just go and convert it. So I could say, okay, degrees over degrees, radians over radians, and cross multiply. So I get 180 x equals 135 pi. And then I would just reduce that fraction. So 135, if I divide the top by 45 and the bottom by 45, believe it or not, it reduces to 3/4. Okay, so that 135 is actually 3 pi over 4. Now I could do the same thing here. I could convert in the same way. 225 over 180 equals x over pi, and I would get 5 pi over 4. Those are the two solutions. Okay, so you can just keep it in degrees and then convert it at the end if you wish. I'll do this one here, but I'll try to stick to radians. So sine is positive in the first and the second. It's negative in the third and the fourth. This is the opposite over hypotenuse, opposite over hypotenuse, opposite hypotenuse. So whenever you have a plane 2, that's a 1, 2 square root of 3 triangle, okay? Again, if I want to add my negatives, I don't really need to. Really what I want to know is, I want to know that that's 30. So again, kind of thinking in radians again, if reference angles are 30, I'm going by 6. I'm going by 6. So, this is, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6. And this is 8, 6, 9, 6, 10, 6, 11, 6 pi. Okay. So again, you can just do it like we were doing before. And then once you find your answer in degrees, you can convert it. But try as much as you can to think in radians as well. Okay. Now, tan. So we're just going to do a couple more slides here. Tan is 1. So remember that tan and cotan, when they're 1, those are actually triangles. I know it seems like it should be on the circle, but it's not. So 1 over 1, and it's positive in the first and the third quadrant. Opposite over adjacent. Opposite over adjacent. Opposite over adjacent, and every time we have 1, 1, it's that kind of a triangle, which is the 45. So again, thinking in radians, 0, I'm going by fourths. 1/4, 2/4, 3/4, 4/4, 5/4. Okay, so where is the tan equal to a ratio of 1? At pi over 4 radians and 5 pi over 4 radians, or it's the same as 45 degrees and 225 degrees, but here we want our answers in radians. Where is tan negative? Well, tan was positive in the first and the third. It's going to be negative in the second and the fourth. So our opposite over adjacent, our opposite is square root of 3, our adjacent is 1. Square root of 3 over 1. So this is a 1, 2 square root of 3. This is supposed to be a 1, it's not a tick. And again, I'm not going to, you know what? I'm not even going to bother to label my angles or my sides because I don't care. I just want to know what is across from square root of 3, and that is 60. So when we're going by chunks of 60, that is thirds. So 1/3 pi, 2/3 pi, 3/3 pi, 4/3 pi, 5/3 pi. So my two answers, the two angles, are at 2 pi over 3 radians and 5 pi over 3 radians. Okay, and finally, what happens when we get 0 and 1 in terms of sine and cosine? And those we know are on the circle. So in both of these cases, just like I did last time, I'm going to draw my zeros and ones. So this is what -1, 0, -1, 0, and this is 0, -1. And I want to know where the cosine is 0. So remember, cosine is the x value. So we're looking for cosines equal to 0. So it happens here, and it happens here. So that looks like 90 and 270, but of course we want radians. 0, pi over 2. It occurred at pi over 2, pi, and 3 pi over 2. So where is the cosine 0? At both pi over 2 and 3 pi over 2. And finally, sine to the -1. Again, this is a special case because it's a 1 or a -1 or a 0. And so sine now is the y value. So where is the sine equal to -1? Where is the sine equal to -1? Well, so it's not at 0. It's not at 90. Nope, it's not there either. I better get that out of there. I better get that out of there. It is right here. That's where the sine is -1, only there. Now that's the same as 270, but it's also the same as 0, pi over 2, pi. It's the same as 3 pi over 2, where the sine is -1. Okay, that's it. So it's the same idea. Again, we're putting a lot of stuff that we already know together, and I know it's difficult doing it in radians. But this is really similar to the last unit where given an angle, find the ratio. It's just, or I'm sorry, in this case, given the ratio, find the angle. It's just in this case, we do not want our answer in degrees. We want our answer in radians. That's it for this lesson.